Evaluate the integral, integrate from 0 to 1, x plus 1 dx over x squared plus 2x plus 2. So the first thing, when you see such kind of cases, try to test if it is algebraic substitution, okay? You first test if it is algebraic substitution before you go to an extent of resolving into partial fractions. Are we together? So how do we test that is an algebraic substitution? Check what is in the denominator, okay? Check what is in the denominator. So denominator we have, if you let u to be x squared plus 2x plus 2, if you differentiate to u with respect to x, do you get what is in the numerator? Or do you get a form which you can integrate? Then you use algebraic substitution on the spot. Are you seeing that? So if you let u to be x squared plus 2x plus 2, if you differentiate u with respect to x, what do you get? 2x plus 2, isn't it? So if you take dx the other side of the equation, what do you get? du is 2x plus 2 dx. You check. Is this what is in the numerator? If it is not in the numerator, then that method is not applicable. It is the algebraic substitution which is usually tested first when you have polynomial functions. Are you seeing that? Are we together? Yes. When you have a case of a partial fraction. So a case of a partial fraction, the first thing you test is algebraic substitution. So when algebraic substitution fails to work, then you go to resolve into partial fraction. So you see, algebraic substitution is working, meaning we don't resolve that problem into partial fractions. Are we together? Because what is in the numerator is 2x plus 2 dx. See, this is x plus 1. See, this is the same as multiplying by 2 and dividing by 2. By 2. Are you seeing that? See, if you multiply by 2, it's like you multiply by 1, isn't it? So that you have 2x plus 2. So you see, you have 2x plus 2 dx. Are we together? Isn't it? So if you take 2 inside the bracket, it is 2x plus 2, which is 2x plus 2 times dx. 2x plus 2 dx, meaning the whole of that numerator is du. Are you seeing that? The whole of that numerator is du. So if the whole of that numerator is du, you can now see, if you substitute, it is 2x plus 2 dx over x squared plus 2x plus 2. So there you see 2x plus 2 dx is the same as du over x squared plus 2x plus that is u. So what is du over u? It is ln of u. Isn't it? See, du over u is ln of u. dx over x is ln of x. Can you remember? Integrating functions which result into logarithmic functions, isn't it? Yes. Yeah, dt over t, integrating dt over t, ln of t, isn't it? So from there, can you now substitute the value of u? It is ln of, where there is u, you put the value of u. What was u? U was x squared plus 2x plus 2. So you now go back to your original problem. What do we have? We have a half into this, isn't it? Remember, your integral was x plus 1 over x squared plus 2x minus 2 dx, which we've transformed to be a half into 2x plus 2 dx over x squared plus 2x plus 2, which is now going to be a half into this. The whole of this integral you found to be ln of x squared plus 2x plus 2. So the whole of that is now, when we don't have z here, we have limits from 0 to 1. You now put your limits from 0 to 1. From 0 to 1. We no longer have indefinite integral. It is now definite with the defined boundaries, isn't it? Are you seeing that? So can you now start substituting upper limit minus lower limit? A half is a constant, you can factorize it outside, because this is ln, you can even put it to the power, whichever way you put it, isn't it? Are we together? So here, if you factorize a half, is a constant can be factorized outside the bracket, isn't it? So we have a half into upper limit minus lower limit. So when x is 1, where there is x, you put 1, isn't it? Where there is x, if you put 1, you have 1 squared plus 2 into 1 plus 2. What do you get? This is 1 plus 2 plus 2, 5, isn't it? You get ln of 5. When x is 0, where there is x, you put 0. 0, 0, you remain with ln of 2, isn't it? ln of ln of 2. So what do you get to be the answer? ln of 5 minus ln of 2, then times 1 over 2. Can you do that? ln of 5 minus ln of 2. ln of 5 minus ln of 2. What do you have? You see, you don't even need to waste your time saying ln of 5 minus ln. This is loss of logarithm. Loss of logarithm. ln of 5 minus ln over 2 is just a half ln of 10. Because when you take it, it is just ln of 5 over 2. When you take the log inside, division changes to subtraction. So it means ln of 5 minus ln of 2 is the same as ln of 5 over 2. Loss of logarithms. So what do you get? The ln of 5 minus ln of 2? 0.9163. And when you get ln of 5 over 2? So you get the same answer? Yeah. 0.9162, isn't it? If you multiply by half, you get your answer, or you leave it like that. There is no problem. Are we together? Then you multiply by half, you get 0.458. So you have here is 0.458, that is 0.46 approximately into 2 decimal places.